Okay, let's see, our last portion of our packet here, the last one we're going to do, let's pick it up. 28, we got our writing pins out. 28 is H, 29 is E, 30 is J, okay, 31 is E, 32 is G, 33 is E, 34 is H. All right, flip over here. Bless you. 35 is C, 36 is J, 37 is A, 38 is K, 39 is D, 40 is K, 41 is A, 42 is G, 43 is C, 44 is F, 45 is A, 46 is J, and 47 is B. Now, do any of those need to be repeated? No, we're good. All right, let's go back up to 28. Start on that column. All right. 28, 29, or 30? Okay, 29. Now, got to keep in mind here for a second that, like, I did these problems like a week ago. So, let's see. A number is located at negative 2.5 on a number line below. One of the following number lines shows the location of A squared. Which number line is it? So, what you want to look at is A squared, where A is negative 2.5. Okay, one of the following number lines shows the location of A squared. So what I'm doing is I'm taking negative 2.5 and squaring it, right? So in your calculator, you need to make sure that you put negative 2.5 in parentheses. A negative times a negative is a positive. 2.5 squared is 6.25, or 6 1/4. Okay? So you're looking at a positive 6 1/4. So you should get E. My guess is you put in negative 2.5 squared without the set of parentheses. What was your answer on it? Did you get A? You got D. Oh, I know what you did. You didn't take 2.5 and square it. You took negative 2.5 and multiplied it by 2, right? So negative 2.5, yeah, times 2, you would have gotten 5, right? Okay. Yep, that's what happened. All right. Anybody else, 28 or 30? Okay, what about 31 through 34? Nobody on those? Okay. Flip on over here. 35 or 36? Okay. 35. Okay, so we're basing this upon this picture. Mr. Smith plans to build a 3-foot wide walkway around the outside of the cabin as shown in the floor plan. What will be the area in square feet of the top surface of the walkway? So it's really just the area, right? Okay, so all you need to do is just find the area of the shaded region around the house, correct? Okay, so all I did here is I broke it into some rectangles. So like here, they tell me that it's 3 foot, so I'm doing 36 times 3, right, which is 216, because I'm doing 36 times 3, and I have another one over here. So it's really 36 times 3 times 2, okay? Does that make sense? And so that's giving me 216. And then because this is 3 foot wide and 3 foot wide over here, I'm going to subtract 6 from this 30 feet long. Right? So it's giving me a 24 by 3 by 2, okay, which is 144. Okay, so 216 plus 144 comes out to 360. Okay, now you could have done that differently. Obviously, we could have done, you could have done 30 by 3 by 2, but you would have had to make sure to cut off 3 here and 3 here. And that actually probably would have been easier because then we would have wound up with a 30 by 3 by 2, okay, actually kind of all the way around, okay? But we still would have wound up with 360. So hopefully that makes a little bit more sense. What were you guys' answers on that?
396? Yeah, 396.
Okay, and how did you end up kind of overlapping at some point there, or what did you do differently?
30 times 3 and added it 36 times 3.
Okay, so technically 396, you said you took 30 by 3. Okay, so yeah, there is, if you do that, you are overlapping. You said 36 by 3 plus 30 by 3?
Yeah.
I'm wondering why that comes out to greater than 360. 30 by 3. Because 30 times 3 is 90, plus you said 36 times 3?
Yeah.
So that's 198.
And then I took that times 2.
Okay, so when you multiply all of that by, well, whenever I multiply that by 2, I get 576. But in any case, if you do that, you're for sure getting overlaps in all of these corners. Okay, I don't know if your numbers are coming out right or not for that, but you are getting overlap. And so you are going to wind up with more than you should. All right, anybody on 36? No? All right, what about 37 through 40? Nobody on 37 through 40? Not even 38? 38, I kind of had to solve through.
Yeah, 38 and
38,
I think that's
Yeah, on 38, it says which of the following is irrational. So all I ended up doing was simplifying all of them, which if you start at the top and work your way down, it's going to look a little bit like this. I multiplied by square root of 8 times square root of 8, which is giving me square root of 16 over 8, which is 4 over 8, which is 1/2, which is rational, right? Okay, you can do the same thing here where you're doing square root of 2, square root of 2. That's giving you square root of 16 over 2, which is giving you 4 over 2, which is 2, which is rational. Square root of 8 squared, okay, is 8. And square root of 2 times the square root of 8 is square root of 16, which is 4, which is rational. But you cannot add unlike square roots. They're not like terms. And the square root of 2 is an irrational number, right? And so is, technically speaking, the square root of 8. So two irrational numbers added together are going to remain irrational, okay? So I felt like that was fairly quick to do to disprove at least the top ones where I can see, hey, all of those are rational numbers. Did anybody run? You said you were close on time just because you spent some time on the actual ACT test with some harder questions and ended up not having some time on some easier questions. Were you still able to get done in time?
I marked them all. I had like 5 questions left.
So 5 questions that you didn't get to go back and make sure you got right.
Yeah.
Okay. Still, that's going to be, I'm worried about if you hadn't had this class, would you have left those blank?
No. Oh, yeah, I would have.
Yeah. Okay. All right, what about 39 and 40? Any of those? All right, let's hit up our last page. 41 through 43. 41 and 43? Okay, so all of this column then. That's fine. All right, 41, the frequency chart below shows the cumulative number of Mrs. Hernandez science students whose test scores fell within a certain score range. All test scores are whole numbers. How many students have a test score in the interval of 71 to 80? Okay, so we are looking, this is the tricky part, is that this is 65 to 80. This is 70 to 80, so we're looking at what exists kind of in that particular range, okay? So let me see if I can make this make a little bit more sense. So it's the same number of students, okay, overall. They're just looking at different ranges and where students fit in. So a student could fit into and be counted more than once, right? Especially if they scored a 65, they're going to show up in all four numbers, all right, in all four ranges. But we're specifically looking for students that show up in this in the 71 to 80 range. Well, we don't have a 71 to 80 range. So what we have to do is we have to look at the to 80 range and eliminate the 65 to 70, okay? So all we're doing there is we're taking 13 and we're subtracting 12. Okay, there is only one student that would have scored from 71 to 80. Does that make more sense? And we see that now? Okay. All right, because everybody in the 65 to 70 range is included in the 65 to 80. Okay? All right, 42. 42 is one I had put a star next to. Hello? She hasn't showed up to my first hour class. Uh-huh. Okay. All right, thank you. Bye. Okay. All right, let's see. 42. Number of decibels D produced by an audio source can be modeled by the equation decibels equals 10 log intensity over constant. Okay? I is intensity of the audio source, K is a constant. How many decibels are produced by an audio source whose sound intensity is 1,000 times the value of K? Normally what we would do is we would solve for K, right? But we can only solve for K if we know how many decibels there are. So I have two unknowns in this. And so, but it's just 1,000 times the constant. So could I pick a number for my constant? The easiest number to pick for my constant is what? 1, okay? So if I do that, D equals 10 log 1,000 over 1, right? Well, can I simplify 1,000 over 1 to just be 1,000? Okay? So all I have to do with my calculator is do 10 log 1,000. Because the base is automatically going to be 10 because there's nothing there. So let's just do 10 log 1,000. What do you get? You get 30. Does that make it a lot easier? And you could have picked another number, but like let's say K had been 2, right? Well, then my I would have been 2,000, right? Which would have reduced down to 1,000, right? No matter what I do, the fraction is always going to reduce to 1,000. I'm always going to wind up with 10 log 1,000, okay? All right, 43. Mario plays basketball on a town league team. The table below gives Mario's scoring statistics for last season. How many points did Mario score playing the basketball season last year? Okay, this comes down to what different shots are worth, okay? Because we want to know how many points. Okay, this is, yeah, I almost missed this. So the first thing I need to do is I need to find out what this number actually represents. What is the, if I attempt 80, if I shoot 80 free throws but only make 75%, I'm going to take 80 times 0.75, right? That's 60, okay? So, but how many points is a free throw worth? So 60 times 1 equals 60. Okay? I'm going to do the same thing here. I'm going to take 60 times 0.9. What's 60 times 0.9? 108. But yeah, it's 54. Okay, it's 54, but 2-point field goal is worth 2, right? So I'm getting 108 points for those 2-point shots, right? Okay, and then I have 25% of 60. Okay, so 60 times 0.25 is 15. Okay, he's making 15 3-pointers. Okay, but he's getting 3 points for every one of those, so he's getting 45 points. So 60 plus 108 plus 45 should come out to 213. Okay, so you just made these 54 and 15 instead of multiplying them by 2 and 3. Okay. Yep. Yep. That was one I think I spent a little bit of time. I scratched my head there for a second. All right. 44 through 47. 46? 45 and 46. Okay. Okay. Let's see. Toby wants to fill the volume of a solid toy soldier. Let's see. He fills a rectangular container 8 centimeters long, 6 centimeters wide, and 10 centimeters high with water to a depth of 4 centimeters. Okay, so that 10 centimeters doesn't really matter because he's not filling it all the way up. Okay, he's got a container, he's not filling all the way up. So if we want to know the volume of water, it's really 8 times 6 times 4. Okay? Okay, and let's see. Toby totally submerges a toy soldier in water. The height of the water with the submerged toy soldier is 6.6 centimeters. Which of the following is closest to the volume in cubic centimeters of the toy soldier? So what I would do is, what is 8 times 6 times 4? What's that? 192. The other thing that you could do that might be quicker is to subtract 4 from 6.6, right, which should be 2.6. And so we could just do that where we're doing 2.6 times 8 times 6. I shouldn't mix my multiplication symbols there, but 2.6 times 8 times 6, and I should get 124.8, okay, which is going to be closest to 125, okay? Let's see, and then what did we say, 46? 46. Let's see, 45, was that yours? Okay. Did that make sense to you? Okay. All right, 46, a box in the shape of a cube. Okay, it has an interior side length of 18 inches and is used to ship a right circular cylinder with a radius of 6 inches and a height of 12 inches. The interior box not occupied by the cylinder is filled with packing material. Which of the following numerical expressions gives the number of cubic inches of the box filled with packing material? Okay, so it is a cube, 18 by 18 by 18, right? So the volume of the cube is 18 cubed. Does that make sense? Okay, and then we want to subtract the volume of the cylinder. Okay, well, the volume of a cylinder formula is going to be pi r squared times height, right? So we need to subtract pi, and the radius of it is what? 6 squared times, and what was the height of it? 12? Okay. Let's see. And so that's what we're seeing right there. Okay. What did you end up going with on that one?
I did
G. You had circumference instead of area. So, okay. All right, any other questions? Okay, we'll stop it right there.